Good afternoon. Welcome to this video about paper review on wheel detection with machine learning. In this paper, I came across some key terms that I'd love to introduce, and that's wheel detection, and machine learning. This project incorporated so many things. More so, the project was trying to focus on how to use machine learning in detecting the defected wheels for a train. According to the review, I found out that the project had a very good objective of aiming how to use the machine learning to detect the wheel defects on freight trains in order to prevent damage to the train infrastructure. Yeah, of course, everything that comes on board with issues, it has to be detected in some sort of way. And this project actually came on board to fix some of this. The problem started here is the project identified the issue in relation to how the infrastructure of railway is affected, and in this paper, it found that the wagons usually lead to extensive damage on the rail infrastructure and it needs to be fixed. And this project came on board and fixed this through so many ways that the problem here in my reviewed paper will explain in deep for the people who are going to go through it. But to hint on it, it says early detection of serious wheel defects on freight trains are an essential part in preventing damage to the railway infrastructure, in providing the train operators with timely information on how to fix some of these issues that come on board. The methodology employed on this project took about 2 machine learning methods which could automatically detect the defected wheels. The first methodology was based on the novel features of classifying time series data, and it is used for classification with support vector machines. The second method employs the deep convolutional neural networks to also automatically learn some features from the time series directly off from a 2-dimensional representation. Although this was a success in the methodology just reviewed, I found out that the project also had some weakness. So the weaknesses observed in this project assume that the proposed methods do neither require a model of the measurement system nor of train dynamics of the wheel defects. The methods enable prediction of defects on wheels where there is no prior understanding of how these defects manifest themselves in the measurement. Okay, the features are developed for the use in supervised learning, are general and can in principle be used for any time series data and are not restricted to the specific defect types, in this case for this sort of project. The technology employed here was motivated by the recent success of artificial neural networks for image classification. This neural network approach improves the performance on wheels with flat spots and roundness by explicitly modeling the multi-sensor structure of the measurement system through multiple instance learning and shift variant networks. That's the technology that was employed here. The contribution of the project, the main contribution of this project had 2 methods of automatic railway wheel defect detection and classification through the vertical force measurements of trains running in full operational speed. That was their contribution. In some of the related works to this project, they employed some certain methods as compared to what this study took. With the related other works, they use some sensor systems for wheel defect detection on freight trains. This works analyzes the signal from acceleration sensors and demonstrate that see they can visually see difference between the measurements of the wheels, which the current project does not look at that. The current project now goes to look at how machine learning will help to, to, to detect the defected tires using the defect classifier, which has a general advantage actually in the measurement system, and it is relatively cheap, doesn't cost too much. The algorithm used and employed in this project were the convolutional neural networks and the deep learning as the deep neural networks. This project employed some data sets and the models, and the data set mostly used here was the wavelet SVM data set. The findings, according to the reviewed paper, the study found three metrics for performance of evaluation of this, which it looked at. It found that the accuracy, precision, and recall were the key findings in this paper. The study concluded that yeah, though though there were recent developments and success in other things, this study still presented two methods in machine learning that could help sort out the problem studied. And the methods analyzes multiple time series of vertical force of wheel under what? Operational speed output if a wheel has a defect or not. Both methods were trained automatically on measurements gathered from defective and non-defective wheels. The study decided cyclic shift invariant artificial neural networks for detection of wheel flats and non-round wheels that model the relationship between the measurements inherent to these defects. So to evaluate some of these methods, two data sets were employed to come up with a conclusive way of how to handle the defected wheels. Some of the recommendations out of the paper included reducing the wheel defects by wheel maintenance, significantly reducing the vibration and noise emissions directly. The study recommended use of timely and targeted maintenance of train wheels as an economic means to reduce emissions. Another recommendation was use of class probability estimates for each class when implementing such systems and adopting a threshold for raising an alarm iteratively based on the test performance of the system. Some of the future works looked in this study, yeah, okay, that can be drawn from this study are to improve the classification performance for flat, spot, and non-roundness in next section by using a custom deep neural network that is cyclic shift invariant for classification of these defects. This is aimed at integrating external features into deep learning models, optimizing for precision and predicting severity scores for the defect. I think in brief that can summarize about the project studied in this case. I thank you.